Hi everyone, today we're going to be talking about prime factorization. Now, prime factorization is the process in which you break up a number until you are left with prime numbers. So examples of prime numbers are 2, 3, 5, 7, 11, 13, and 17. Now, why are they called prime numbers? Well, think about it. If we look at number 2, well, give me two numbers that multiply together, give me 2. Well, you would think 1 and 2, right? That's the most simple and the most basic thing that you can think of, right? Yeah, that's right. Now, can you think of anything else that'll give me 2? No. Well, 2 is just 1 and 2. So that's why it's called a prime number, because they are two factors, meaning that they can only multiply by 1 and actually themselves. What about 3? Well, I'm thinking about 1 and 3. 1 times 3 is 3, which is true. Anything else? What about 1.5 times 2? Well, 1.5 times 2 is indeed 3. But the thing about when we're multiplying or when we're considering in terms of prime numbers is that we're dealing with positive whole numbers. So 1 and 3 are whole numbers, but 1.5 isn't. So we can't use 1.5 times 2 equals 3 in this case to consider that it is not a prime number, if that makes sense. 5, well, 1 and 5, 7, 1 and 7, 11, 1 times 11, and so on and so forth. So now we're going to look at number 1, which says write the prime factorization of each number. I look at number 8. It is not part of my list at all, because 8 is not a prime number, but we can write it so that we can break it up and make it all prime factorized, if that makes sense. So again, prime factorization is the process in which you break up a number until we are left with these prime numbers here and there. Okay, number 8. So number 8, I'm going to do something called a factor tree. It's called sort of like a family tree, but here goes something. So I'm going to draw this weird looking tree or this caret sign, and then I'm going to think of two numbers that multiply together that'll give me 8. So in the case of 8, 4 and 2, because 4 times 2 is indeed 8, right? Now, again, I am trying to break this up until I have prime numbers. 4 is not a prime number. That means we have to keep on going and break it up. So 4, I'm going to draw a caret sign under the 4, and I'm going to think of two numbers that multiply together to give me 4, 2 and 2. Yes, 2 times 2 is 4, and then looking at our list, or looking at our factor tree, I am now left with prime numbers. I'm just left with 2's. So how many 2's do I have? Well, I have 1 2 here, another 2 here, and another 2 here. So then I'm going to write out everything. I'm going to write out my primes here, and then I'm going to separate it with a multiplication sign. So I have 2. That's from that 2. And I'm going to write another 2 here. That's from this 2 here. And I'm going to write another 2 here, and that's from this 2. I am not including the 4 because it is not a factor. Or I'm sorry, it's not a prime number, so I'm only working with the numbers that are prime. Okay, so 2 times 2 times 2, we can write this in the form of an exponent, right? Which is, well, I have my base, which is 2, and then since there's 1, 2, 3 2's, I write that as an exponent of 3, so 2 to the 3rd power. So this right here is already in the form of it's already prime factorized, and this is my answer. Okay, hopefully that makes sense. Let's take a look at number 2. Number 2, I'm dealing with the number 24. 24 is not a prime number, so I need two numbers that multiply together that give me 24. So I'm thinking 12 and 2, because 12 times 2 is 24. And then, okay, well, I can't break this up because this is already a prime number. So 12 in this case, I can break that up because that is not a prime number. And I'm thinking 6 and 2 because 6 times 2 is 12. And then I'm going to break up the 6. I'm going to go ahead and put 3 and 2. And then I am left with prime numbers, right? 3 is a prime number because it can only be multiplied by 1 in itself. So let's write our lists. We have, well, a 3 here, so I write 3. I'm going to separate with a multiplication sign. Here's another 2, or sorry, here's a 2. Oh, what did I do? Here's a 2. And then here's another 2. And then here's another 2. So then I'm going to prime factorize this. Well, I have a 3 here, so I'm going to write a 3. And then this 2 to the, I have 3 2's that can be represented as 2 to the third power. And this is my answer. Okay? So then I'm going to look at number 3. I have a 40. Sorry, that's not 4. So that's 20 and 2. Can break down the 20, which gives me 10 and 2. And then I can break down the 10, which is 5 and 2. And now I'm left with these primes here. So I'm going to write 5 times 2 times 2 times 2, which can be represented as 5 times 2 to the third power. Okay. Now I'm going to look at 98. Well, I have 49 times 2, and then 49 can be broken down as 7 times 7. So then I'm left with these primes, so I'm going to write 7 times 7 times 2, and then I'm left with 7 squared times 2. This is already prime factorized. Now we're going to go ahead and figure out the greatest common factor of numbers. So if we're taking a look at number 5, we have 24 and 60. Now before I delve into 24 and 60, I want to go ahead and just note some key words from this jumble of stuff here. So we know what a factor is, what numbers that go into something, right? And then we know what the word common is, something that one thing and another thing share. Like, what do they have in common? What do they have in terms of, having the same thing, right? And then later on, I'm gonna figure out what the greatest common factor is. Greatest means what is the largest out of whatever I'm dealing with. So let's take a look at 24 and 60. So 24 and 60, I'm going to break them down, just like what I did in problems 1 to 4. So when I'm looking at the number 24, I'm going to think of two numbers. That multiply together to give me 24. Well, 12 and 2. And then I know that 2 is a prime number, so I'm not going to break that down. But 12 isn't, so I'm going to go ahead and break that down. So that's going to give me 6 and 2. And then I look at number 6. I'm like, okay, I can break that down. So I might have 3 and 2. And then I am now left with my prime number. So I'm going to write it here. So factors of 24. And I'm going to go ahead and list out the prime numbers that after breaking that down. So I have 3, which came from this 3. And then 2, which came from this 2. And I'm going to go ahead and write the rest, all right? So separating by comma, 3, comma 2, comma 2, and comma 2. And remember, when you're listing things, you either bullet point or use commas to show what you're doing, right? When you're listing things, you use commas or bullet points. Okay, so I'm going to look at number 60. 60, I can break that down, 30 and 2. And then 30 can be broken down as a 15 and 2, and then 15 can be broken down as 5 and 3. Okay, so go ahead, I'm going to write my list, factors of 60. I'm going to go ahead and write 5, 3, 2, and 2. And then I am done with this part. Now I'm going to figure out what this part is. What do they have in common? I have a list of list of factors of my 24 and then list of factors of my 60. I'm going to go ahead and figure out what do they have in common. So let's zoom in and figure out Okay, well, I see that I'm going to indicate with a highlighter that the factors of 24, they have a 3, and the factors of 60, they also have a 3. So let's highlight that. So this here has a 3, and this here has a 3. And I'm going to write my 3 right there, okay? And then I'm going to go ahead and see that this here has a 2 and this here has a 2. So I'm going to go ahead and separate that, or put that right here, and I'm separating with a multiplication sign, so do that too. And then lastly, what do we have? Well, I see that this here has a 2 and this here has a 2. So I'm going to go ahead and write another 2 down below. So yes, this here has a 3 and this here has a 3, and this here has at least a 2, and this here has 2 2s as well. I'm not going to include this 2 because this when I'm looking at the factors of 60, it doesn't have the 2, so I can't write another 2 here. I'm only dealing with what they have in common, so please keep note of that. Only what they have in common. So now that I figure out what they have in common, I'm going to go ahead and figure out what the greatest or the largest factor in this case. Remember, factor goes into factor means what is the largest number that go into 24 and 60. Well, let's take a look. We have this all written now. This is our when we figure out the common factors. 3 times 2 times 2. Well, we know that 3 times 2 is 6, and 6 times 2 is 12, sorry. So this right here, 12 is my greatest common factor, right? Because 12 goes into 24 and 60 at the same time, and it's the largest number that go into 24 and 60. 3 goes into 24 and 60, but it's not the largest number. 2 goes into 24 and 60, but it's not the largest factor. 2 here, same thing, right? So 12 in this case is the largest number that go into 24 and 60 at the same time. Okay, so this is my greatest common factor. Number 6. I'm going to do the same procedure here. So 18, I know that I can write that as 9 times 2. And then I'm going to break down this 9. That's going to give me 3 times 3. And then these are my factors. So let's write factors of 18, which are 3, 3, and 2. And then I'm going to write factors of 27, but I haven't broken that down yet. So 27, I know 2 numbers that multiply together, that's going to be 9 and 3. And then I'm going to break down this 9. I'm going to be left with 3 and 3. And then I'm left with all these prime numbers, right? So if I go up here, yes, 3 is a prime number. So I'm kind of done here. So I'm going to write 3, 3, and 3. All right, now I'm going to look at what's common, right? So I got my factors. Now I need to figure out what they have in common. What do 18 and 27 have in common? So using my highlighter, well, I see there's a 3 here and a 3 here. And then I see a 3 here and a 3 here. And then I see that there is a 2 and a 3 here. So that means that there's a 3 here, but there's not another 3 here. And then there's a 2 here, but there's not another 2 here. So I'm going to go ahead and exclude that. I'm going to work with what they have in common. There is at least 1 3 here and another 3 here. So that's going to write 3 times 3, and 3 times 3 is 9. That means that 9 is my GCF, the greatest common factor, because 9 goes into 18, 9 goes into 27, and it's the largest number that goes into both of these numbers here. Once again, 3 does go into 18, and this 3 goes into 27, right? But it is not, so 3 is a common factor, but it's not the greatest common factor, because 9 is the largest number that go into 18 and 27. Okay. All right, so now we're going into a different territory, but the same procedure. This time we're dealing with variables. This time we're going to be dealing with a variable raised to some sort of exponent. So notice that we have an x cubed and an x squared here. So let me go ahead and recall some of the things that we've already learned from the previous units. Well, we know that x times x is x squared, and x squared times x is x to the third power, right? Because all I got to do is that when I have the same base and I'm multiplying, all I got to do is add those exponents. So invisible 1 here, invisible 1 here, 1 plus 1, that's going to give me 2, right? Here's a 2 here, and here's this invisible 1. So 2 plus 1 is going to give me 3. So remember, I'm dealing with the same base, and I'm multiplying. All I got to do is just add those exponents. Now, here's the thing. When we're trying to break something up, remember we were breaking things up like this, right? All I got to do when I'm breaking down, our variables is that we know that x squared is the same thing as x times x, right? That's just the same thing that we know here. We're gonna go ahead and do the same thing when we're breaking them down by looking at number 7. So all I got to do is I'm gonna just separate this a little bit, but they're together, right? They're together because they're multiplication, right? 3 times x cubed is the same thing as 3x cubed, but I'm gonna go ahead and just break this down. So I look at the 3, and I know that I can, 3 is a prime number because 3 times 1, and I can't do anything else. So I'm just gonna leave it as is. So I'm just gonna put a 3 here, and then x cubed. Can I break that down? Yes, I can, right? We know that x cubed can be rewritten as x times x times x. So then I'm going to go ahead and put factors of 3x cubed, which is 3x, x, and x. Okay. And then I'm going to go ahead and look at 15x squared. Well, okay, I'm going to look at the 15. Well, 15 is the same thing as 5 times 3, and these are my prime numbers, so I'm just going to leave it as is, because I can't break down the 5, and I can't break down the 3 at all. So then I'm going to look at the x squared. I'm going to go ahead and just multiply that by x times x, because we know that x times x is the same thing as x squared. Okay, let's write down the factors of 15. Of factors of 15 x squared, which is the same thing as 5 comma 3 x and x. I don't know why I said same thing. I'm just saying I should have said factors of 15x squared is 5, 3, x, and x, right? Okay. Anyways, let's figure out what do they have in common. Remember, that's my second step, to figure out what's in common, and I'm going to go ahead and list them in the bottom and separate it with the multiplication sign, and then figure out the greatest common factor by just multiplying everything out. Okay, what do they have in common? Well, using my highlighter, I see that there's a 3 here and a 3 here, so I'm going to write 3 times something. So what else do they have in common? Well, this here and this here have something in common, so I'm going to write an x. 1 x only, and 1 3 only. And then what else do they have in common? Here's an x, here's an x. So I'll write another x. Okay. So what do? Well, I'm going to go ahead and multiply. Well, 3 times x times x. Remember, there's an invisible 1 as their exponent. So this is going to be 3x squared. This is my greatest common factor, because this can go into 3x cubed and 15x squared at the same time, and we can verify that because 3x cubed divided by my GCF, which is 3x squared, this number goes into here, which will give me, well, 3 divided by 3 is just 1, and then x cubed divided by x squared is just x. This is just saying, okay, 3x squared times x will give me 3x cubed. And then I'm going to look at the 15x squared. Well, 15x squared divided by 3x squared, 15 divided by 3 is just 5, and then x squared divided by x squared is just 1. So that means that, okay, yes, 3x goes into 15, 3x goes into 3x cubed, and then 3x squared times 5 will give me 15x squared, okay? So that's my GCF. So this is my answer. Don't worry about this. I'm trying to explain what we're doing because, again, I'm trying to find the greatest common factor, which is the largest number that goes into 15x squared and 3x cubed at the same time. Okay. All right, number 8. Let's do the same procedure. Okay, well, let's break this down, this 4, 2, and 2, and then I'm going to break down this x squared here, so that's x times x. Right here, that's just 5, and it's a prime number, so I can't do anything else. I can't break that down even further. And this y cubed is y times y times y. So let's write our factors. Factors of 4x squared, which is just 2x and x, and then factors of 5y cubed, which is 5y, y, and y. And what do they have in common? So if we take a look at 4x cubed and 5y cubed in terms of their factors, well, they don't have anything in common, so this is just nothing in common. They're just prime numbers. That's my answer. I don't have anything. I don't have a number that goes into 4x squared and 5y cubed. And if I don't have a number that goes into 4x squared and 5y cubed, that means that there's no greatest common factor at all. There's no largest number that go into this number and this number at the same time. One thing that I want to note, because I didn't... These things that we were looking here, these factors, are actually prime factors. So I just made a mistake and I wasn't being clear enough. We were looking for prime factors. Yes, there are factors that aren't prime. For instance, this right here, that isn't prime, but it is also a factor of 18 and 27. So you should make that note when you're doing your notes, making sure that these are called, or clarifying or noting that these are prime factors, okay? Anyways, so I'm going to go ahead and discuss the rest of the problems. We got some binomials here, we got some polynomials here, and what I want to do before I discuss these problems is that, you know, in the previous unit, we were talking about distributing or multiplying polynomials by a monomial or polynomial by a polynomial. For instance, we have 2x times, let's say, x plus 2. And then what you have to do is that you're going to distribute both of them, which you will get 2x squared plus 4x, okay? So what's going to happen in this unit is that we're going to have our final result, which is this, and then trying to undo that distribution. So this is what we're going to do. We're going to take this and we're going to revert it back to where it was before. Okay? So this is what we're going to be looking at, and we're going to be using the GCF to figure that out, okay? So notice that we have a binomial here because we have two terms, and what I want to do is I'm trying to look at it, and I'm going to write this out. 4x squared and negative 3x. Actually, let's not put the negative 3x, just put 3x there. And what I'm going to do is I'm going to go ahead and do the same thing as before, just like this, and then see what they have in common. What's the largest common factor, the greatest common factor that we have? Okay, so I look at number 4, I'm like, okay, well, that's going to be 2 and 2, and then x squared is x and x, and then 3x is just 3 and x, right? So here are my prime factors. So looking at this, so 4x squared colon, and then, or colon, sorry, and 3x colon, and then we have 2x and x, and then 3 and x. What do they have in common? Well, it seems like they share only one x's. right? Well, this has another x, but this doesn't, so I can't highlight that. This has a 2, but this doesn't have a 2, and that's just the same thing here. And then this has a 3, but this doesn't have a 3, so I can't highlight those. So here's an x, so that means our GCF in this case is x. Okay, so our GCF is x, but this is not the answer. So I'm gonna write, so what I'm gonna do now is that I'm going to go ahead and put parentheses, and then that x, our GCF, goes right here. So let's put our GCF goes right here. Now, I need, so when we're looking at this, right, this right here is our GCF. This times what is going to give me 2x squared, right? 2x times x is going to give me 2x squared. Now here's our x. X times what is going to give me 4x squared? Well, we know from our factors, this is the x that we took, and we have 2 times 2 times x, which is exactly what I'm going to use. So whatever I didn't use here, whatever I didn't use, I'm going to put it over here. So 2 times x is 4x. And then I have that minus sign, so I'm going to put that minus sign there. And then for this 3x here, so here's our 3x. And what I didn't use, I'm going to go ahead and put it over here. Okay? So I have x times the quantity 4x minus 3. This is now factorized, and this is my answer. And we can confirm that x times 4x is 4x squared, and x times negative 3 is negative 3x. Okay? Now, I'm going to get a little faster, and instead of doing the factor tree, can we just notice things, right? Can we just see it? So let's take a look. If I have 5b plus 9b, well, here's one thing that I always take note of. Okay, well, let's take a look at the coefficients. What two numbers, what is the greatest common factor that go into 5 and 9 at the same time? Well, nothing. I can't think of anything. These two are, I don't have anything that go into 5 and 9 at the same time, so there's nothing for me to do. But we can look at the variables. So we have b and b squared. Well, they both, so these two terms have, these two terms have a b. And what I'm going to do with that variable is I'm going to figure, okay, what's the lowest degree? The lowest degree that go into b and b cubed. Well, we know that b can go into b, right? B divided by b is 1. And then b goes into b3 one time, right? Because b cubed divided by b is b squared. So I'm going to write b here, and then think of the lowest degree, right? And which is 1, so I'm going to put a 1 here, or not. I'm just going to leave it as is, actually. And then I'm going to put those parentheses, and I'm going to say, okay, well, b times something is going to give me 5b. And we know that 5 times b is just 5b. So I'm going to write 5 here. And then next, b times something, that will give me 9b cubed. Positive 9b cubed to be exact. So I'll put positive here. And we know that's just going to be 9b squared, right? Well, if you don't know, well, let's write this on the side. So 9b cubed divided by b, and we know that 9 divided by 1 is just 9, and then b cubed divided by b is the same thing as b cubed minus 1, which is b squared. So that's exactly where I have this here. Okay, hopefully that makes sense. So that's number 10, and this is already factorized, or yes, this is already factored. Okay, here we go. Number 11. All right, now what I'm going to do, again, I'm trying to figure out, I'm going to look at the coefficients, and then I'm going to go ahead and look at the variables. Okay, the coefficients are going to go up in the front, just like this. This is where I place my GCF, and then I'm going to work with I'm going to figure out what I'm going to put in the parentheses. So, okay. let's take a look. Well, what is the GCF that goes into 10, 20, and 5 at the same time? Well, looking at this, I'm like, okay, well, 5, right? 5 goes into 10, 5 goes into 20, 5 goes into 5, right? So I'm going to put a 5 here. And then what else do they have in common? Well, they all have y's, right? So let's put a y there. And then what is the lowest degree that goes into y cubed, y squared, and y to the first power? Well, I see that this is the lowest y value. I'm sorry, this is the y value with the lowest degree with 1, so I'm going to put a y there, which I already did. Now I'm going to go ahead and put the parentheses right after, and then figure out, okay, well, 5y times something is going to give me 10y squared. Well, 5 times 2 is 10, so I'm going to put a 2 here. And then y times y squared is going to give me y cubed. So let's put y cubed there. Y squared there, right? Because y times y squared is y cubed. And if you don't know, just do the math. 10y cubed divided by our GCF. So I'm putting a 5y here. And we know that 10 divided by 5 is 2, and y cubed divided by y is y squared. So I'm going to put it, so that's how I got 2y squared. And then let's see, so we have 5y times something is going to give me 20y squared. Well, we know that 5 times 4, right? 5 times 4 is going to give me 20. So I'm going to put a 4 here, so positive 4, and then y times something is going to give me y squared, which is just y. And to verify, if you don't know, 20y squared divided by our GCF, which I got over here. If we look at that, well, 20 divided by 5 is just 4. And then y squared divided by y is just y. Exactly what we got here. Okay? And then we look at 5y into 5y. Something times 5y is going to give me negative 5y. Well, we know that 5y times negative 1 is going to be negative 5y. So let's put a negative 1 here. Okay? And this is my answer. This is my answer. Okay. All right. Number 12. So, again, I'm going to figure out the GCF, right? The GCF is going to go in front of those parentheses. And then I'm going to figure out, okay, well, look at my coefficients. What is the highest factor that go into 12 and 8? Well, let me think. Well, yes, 2 goes into 12 and 8, but is that the greatest common factor? What about 4? 4, yes, let's put 4 there. Because 4 goes into 12 and 8 at the same time, and it's the largest number that go into 12 and 8 at the same time. Okay? All right, now what else do I have? Well, they both have an x in each term. So I'm going to write an x here and then figure out what the lowest degree is. Well, the lowest degree is just 1, so this is enough to work with. Okay, now I'm going to go ahead and work with the parentheses. Okay, well, 4x times something is going to give me 12x. Well, 4 times 3 is going to give me 12, right? And then I don't do anything else because 4x times 3 is just 12x. All right, now I'm going to go and figure out, okay, well, 4x times something is going to give me negative 8x squared. Well, we know for sure that it's going to be minus 2x, right? And if you can't see that, well, let's just do the math. Negative 8x squared divided by that GCF, 4x, right? So I'm going to put a 4x here, and then I have, okay, negative 8 divided by 4. Negative 8 divided by 4 is negative 2, and x squared divided by x is just x, right? So I'm going to put negative 2x, and that's exactly what we have here. Okay? All right. So now what I'm going to do is I'm going to look at the coefficients here. Okay, so again, this is the coefficient. And we can call this, you can call this y if you want, if that makes sense. You can actually, in an algebra class, you can just make things look more neater, right? We can call this x minus 3 equals y, and then you can replace everything by y if it makes everything look nice, but you got to go ahead and just replace it. But I'm not going to do that because that's going to be a little confusing. We're not at that stage to be comfortable with renaming things with a variable, right? So let's just do it how we normally do it. So what I'm going to do, this is kind of weird. We have this times parentheses minus this times parentheses. Now, this is a term, and this here is a term as well. And what I want to do is I want to go ahead and figure out, okay, well, what numbers go into 7 and negative 2x at the same time? Well, nothing, right? So I'm not going to do anything. But notice over here that this term has an x minus 3 and this term has an x minus 3. Remember, that is our factor, so it's going to go in front of the parentheses. Remember, this is 7 times x minus 3 and negative 2x times x minus 3, right? If I put x minus 3, right, we know that x minus 3 times something is going to give me this, which is just 7, right? Because x minus 3 times 7 is 7 times x minus 3. Yes? Good. All right, so now what I'm going to do is I'm going to put a minus 2x, because you can agree with me that x minus 3, the whole quantity, times negative 2x is going to give me this. And this is my answer. All right. What else do we have? So we're going to look at this, and I'm like, okay, well, what do we notice about these two terms? Well, we can see that there's a negative t here, and there's an invisible 1 there. All right, this is the same thing as negative t times the quantity, t squared plus 4, plus t squared plus 4 quantity. Right? So what do they have in common? Well, I see a t squared plus 4 here and a t squared plus 4 here. So what does that mean? Well, they share the same thing. That means it's gonna go outside the parentheses. Oops, not outside. Oh, sorry, not inside, but outside. And then I'm gonna go ahead and just work with whatever I have. And remember, there's an invisible 1 here, so let's just make note of that. Okay, so t squared plus 4 times something is going to give me this whole thing. Well, there's this negative t here, right? Negative t times the quantity t squared plus 4. So negative t goes right here. And then again, t squared plus 4 times something is going to give me t squared plus 4. And remember that invisible 1, it goes right there. So plus 1. Okay? And that's my answer. Hopefully you're getting a little bit more comfortable. Maybe we're at the stage where we no longer need to use factor trees, but, it's okay if you're still, confused and you want to try and use the factor tree. That's totally fine, because, more power to you. How you want to learn is kind of it's really up to you. I accept, multiple ways. As long as you understand it, then that's good. Feel free to ask questions if you have any. Okay. All right. So what do we know here? Well, what do we notice here? Well, 9x times the quantity x plus 4 minus 5 times the quantity 4 plus x. Okay. You might be looking at this and like, well, x plus 4 and 4 plus x, that kind of looks a little bit weird. But notice that x plus 4 is the same thing as 4 plus x, right? Wait, sorry. Let's write that again. X plus 4 is equal to 4 plus x. Because that's the same thing as 7 plus 2 is equal to 2 plus 7, right? 7 plus 2 is the same is 9, and 2 plus 7 is just 9. This is just rewritten differently, right? So I can just go ahead and rewrite this as 9x times x plus 4 minus 5 times x plus 4. So I'm just rewriting. And now I'm going to go ahead and figure out what my GCF is. The GCF is going to go in front of the parentheses. Okay, so let's take a look at this. Do I have anything that goes into 9x and 5? Well, no. I don't, so I'm not going to do anything there. But I noticed that they do have an x plus 4 here. They both have an x plus 4, so the x plus 4 goes outside of the parentheses, and then I'm going to go ahead and multiply. This is my answer. Alrighty, so what do we have here? Well, we have negative 3x squared times the quantity x plus 2 plus 4 times the quantity x minus 2, okay? So what goes into negative 3x squared and 4? Well, let's use a factor tree actually one last time here. Okay, 3x squared, negative 3x squared and 4. This is going to be negative 3x times x, and then this right here is just 2 times 2. Do we see anything, do they have anything in common? I don't see anything, so no. So, and then we're going to look at the x plus 2 and the x minus 2. The x plus 2, x minus 2, they are not the same thing. They are not the same thing, right? If I say that x is equal to 9, right? If I say that x is equal to 9, and I'm going to replace these x's with 9, so 9 plus 2, and then 9 minus 2. 9 plus 2 is 11. Or is it 11? Yeah, it is 11. And then 9 minus 2 is 7. Are these the same thing? They are not the same thing at all. So this cannot be factored at all. Okay, hopefully that this video helps. I know I'm not really good at recording videos at all. I think that's like my biggest weakness, is just because I don't have like an audience to go back and forth with. So it's kind of weird to, like, you know, talk by yourself about, or talk to yourself about math. But hopefully this video helps. I will try to do more of these because I know that some of y'all are out and won't be able to attend the actual lectures in the classroom. So this is just an alternative way while you're at home. So, and also if you use this video because you wanted to, you know, more clarification, or something was confusing in class and you just want to go ahead and watch the video again, that's totally fine. But, you know, more power to you. So hopefully this video sort of helped. If you have any questions, feel free to shoot me a message. All right, so see ya.